Okay, in this little video, we're going to go ahead and set up a base map for the split-second auxiliary fuel controller used in most fifth port setups. You're going to need three things. You're going to need this spreadsheet. You can download it at permtuning.com. You're going to need ATR with a valid, accurate mass airflow curve. Ideally, you set your MAF calibration up without any kind of auxiliary fuel, no meth, no split-second fifth port, no nothing. Just a true airflow curve. And you don't have to do like watt poles to do this, just accurate MAF cals up to like 100 grams per second or so. And you can usually interpolate out from there and get an idea. A good tuner will be able to set you up if you need. But what this is going to give us is an accurate representation of airflow for each mass airflow voltage. And then from there, we're going to go and calculate the necessary injector pulse widths for use with the auxiliary controller. Lastly, you're going to need the split-second R4 software. This is used to program the fuel controller. So let's go ahead and start out, I guess, setting up the split-second software. The first thing you need to do is come in here and say new customer. And here you're going to say, I am a new customer, or whatever name you want to do, or whatever you want to say to the file. Go ahead and say save. Then you need to come back and you need to open the customer. I am a new customer. Open. We're going to want to set things up here such that this is an example for a pre-throttle body setup, but we're going to want to set it up so that you're a two-cycle, two-cylinder motor. And essentially what that does is it tells the controller to spray the injector on every single crank rotation. Every single pulse from the coil pack will result in one single spray. So you can come in here and you say options, engine settings, 2 cylinders, 2 strokes. The 2 cylinders makes the tach RPM accurate, and then the 2 stroke gives us a spray every single rotation. Go ahead and click the X. You don't have to click save or anything. The software saves as you go. Every time you make a change, it saves. The next thing we need to set up is we want the display mode to be voltage based, and then the application is additional injector controller. Go ahead and click the X. Now we can go and open up our fuel maps, and we'll get to the juicy part. Let's go ahead and look at our worksheet. We're only supposed to modify the yellow cells. So here we go ahead and come in here, and we're going to copy and paste the mass airflow curve from 2.03 volts all the way up to 5 volts. So you go to Access Tuner Race, you find 2.03 volts, click it, go all the way up to 5 volts, highlight them, then just Control C for copy, click this cell, Control V for paste. You can see that it goes all the way to 5 volts. The next field is going to go ahead and pluck out the grams per second for each of the 10th volt steps in our MAF curve. So 2.1, it's going to grab 4057. 2.2, it's going to grab 4619. 2.3, it's going to grab 5556. The next thing we need to do at this point is specify a maximum injector pulse width and a maximum airflow. The maximum injector pulse width for a two-stroke, two-cylinder motor is going to be around 8.5 milliseconds at, say, like 7,000 RPMs. You say 7,000 RPMs divided by 60 gives us 116.7 rotations per second. If you take 1 over that number, you get about 8.5 milliseconds per rotation. So that's our absolute 100% duty cycle maxed out static injector value. So for this example, 7 milliseconds is a good ceiling. Now the airflow is going to be based off the turbo and the power intentions. The next field here automatically goes in and assigns an injector pulse width reference to 500 grams per second. You can see that our 500 grams per second row or column is going to be 7 milliseconds roughly. If we were to find one that was 250, we would get exactly half, 3.5 millisecond pulse widths. So this one went ahead and took our airflow based off the math curve and correlated that to an injector pulse width set max to the max airflow. The next thing we need to do is specify a minimum injector pulse width. In this case, we'll just use 1 millisecond. So this field will actually lop off everything that's out of bounds, either less than 1 or greater than 7. So these will all become 0, and then these will all become 7. And then this last field just gives us the voltages one more time, because we're going to have to manually enter these into the R4 software one at a time. So let's go ahead and go to our R4 software. The thing to do at this point is choose an RPM that you think best represents where you'll see peak torque in a typical pull. Most turbos, 4,500 RPM is a good place to start. So we'll go ahead and use this row to start with. I'll show you how to interpolate for the higher and lower RPMs next. But we got to do the dirty work and actually copy everything over there. So we come in here at 2.5 volts will be the first cell, and we start with a 1.06. So we go 2.5 volts at 4,500 RPMs, and it's 1.06. Then at 2.6 volts, we're at 1.24. 2. Volts, 7, and we know that they're all 7 from here on out. Okay, so now we're going to want to come in here and select our row. We're going to want to copy it using this little symbol. Copy. We're going to want to paste it all the way down here at 8,000s. Our highest row. Click paste. Just use the buttons. Control V, Control C, they don't work. Just use the buttons. You only have to do it once. Okay, so now as you increase your RPM, since we have a tach-based fuel controller, a higher RPM is going to result in more injector openings, thus more fuel going into the motor. So you don't want to keep your injector pulse widths here. For say from 4,000 RPM up to 8,000 RPM, it would result in twice as much auxiliary fuel going in. So ideally what we need to do is scale the higher RPMs down to a lower number. So we're going to go ahead and calculate a ratio from 4,500 RPMs up to 8,000 RPMs. 0.5625. And because the software is a little quirky, you don't multiply by 0.5625. You actually multiply by 1 minus 0.5625 and negative. So 1 minus 0.5625. So we're going to multiply by a negative 43.75. It's a little quirky, but again, you don't have to come in here often. So highlight the whole row, and you want to hit scale by. This one right there. Change by. Negative 43.75. Okay, so things look pretty good. If it were 9,000 RPM, these would be exactly half, but we're not quite double the RPM. So now what we need to do is interpolate down. So you just select each column. It's another little time-consuming bit, but it's not that bad. And you want to use the autofill. So you highlight the column just from 1.1 to 0.6, and you click autofill. And it's just like doing a vertical interpolation in ATR. You don't want to do the whole thing because it'll autofill left to right and up to down. So you got to do it column by column. Just a little annoying, but not the end of the world. Okay, we're going to do this one more time. Go into the lower rows. So we're going to highlight our whole row. Copy it. And paste it maybe down to like 2,500 RPMs. It's not too bad. You can go all the way down to 2,000 for that matter. So then paste. We're going to want to scale this again by the same ratio. So 4,500 RPM divided by 2,000 RPM. So now we want to multiply by a percentage of 1.25 or 125. So select this thing and we say scale by 125%. Cool. And then we go back to the monotony. Autofill. Okay, we're pretty much done. I mean, at this point, you've got a airflow referenced injector pulse width table with both RPM and MAF voltage. Some things to keep in mind. Because we're using 2-cylinder, 2-stroke, this injector duty cycle indicator up here in the top left, not sure if you can see it, but it's up over here. You have to mentally double that number. So in this case, at 2.8 milliseconds, at 5,500 RPMs, it says 25.7%. In reality, that's 51.4%. It's not 25. Again, the software is a little quirky, but it does what we need. And it actually gives you a lot of control over your fueling. So just 2-stroke, 2-cylinder mode, you mentally double this injector duty cycle number reported up there. Another thing to keep in mind is that some regions of this map are just not going to be ever seen in real life. You're never going to see, 8,000. It's rare that you're going to see 7,000 RPMs at 2.6 volts. I mean, you could. It's not a big deal. But like over here at 4.7 volts at 3,000 RPMs, that'll never happen. You're never going to max your MAF at such a low voltage. What you'll end up with is like a trend, like an actual line of best fit, essentially, like a line of a typical spool. And you'll end up with like regions where the motor will actually operate in the real world. And in a later video, I can show you guys how to plot those out using your data logs. But it's pretty much as easy as just looking at your MAF voltage at each of the RPM points. And then you can just kind of highlight some cells and get a sense of like where the turbo's operating. And then from that, you can gain some insight on what injector duty cycles you're actually running on your auxiliary fuel. And then if you want to like bump it up or bump it down, the best way to do it is to do it as an entire map. Because this whole map is set up, and it takes a lot of time to get it set up. So it's kind of nice just to keep the whole thing. If you want to spray half the fuel that you're spraying now, simply highlight the whole area, come in here and just say change by -50. There you go, the whole thing's turned down. Or if you wanted to, I don't know, scale it up, go up 100. We're back to where we were. So, I don't know, I mean, it works pretty good. So at this point, you're kind of got the aux fuel set up. You know that the fuel injection starts at 2.5 volts. So you can come into ATR around your 2.5 volt region and start pulling fuel. And, a good tuner can do this for you. Or if you just do it in baby steps, just a little bit of aux fueling to start with, and then slowly just start bringing down this whole curve, a little bit at a time. And eventually you'll get the whole thing leaned out. Generally, I don't like to leave an abrupt disruption right there, like an abrupt point, so I always kind of like to smooth it out a little bit. But it'll take a little getting used to. I mean, you got to get it tuned. But once you're tuned, it's very reliable. So that's kind of the gist of it.